Hello, welcome again to Jameson Exam Tuition. In this session, we focus on speed and accuracy involving solving of mathematical equations. We have linear equations and the solution to linear equations is not usually a problem. But when you come across an equation having fractions, you begin to have problems. We have the case where you could have to cross multiply at some point when you have a fraction equals a fraction. You simply cross multiply, so AD would be equal to BC. Example, x plus 1 all over 2 equals 2x minus 3 all over 5, for instance. And you simply cross multiply, you get 2 into 2x minus 3 equals 5 into x plus 1. 4x minus 6 equals 5x plus 5. And you collect like terms, you get 4x minus 5x equals 5 plus 6. Negative x equals 11, so that x equals negative 11. Where there are many terms with fraction especially, this is where the split break appears. You have, for instance, x over 6 minus x plus 1 all over 3 equals 1 over 5 plus 2x minus 1 all over 2. Wherever you come across this type of situation, the easiest and fastest way to tackle it is to multiply through by the LCM. And the LCM should be 30, so I would multiply every term by 30. I'll get 30 into x over 6 minus 30 into x plus 1 over 3 equals 30 into 1 over 5 plus 30 into 2x minus 1 all over 2. Simplifying, we'll now get 5x minus 10x minus 10. 3 cancels 30 to give 10. 10 expands across the bracket there to give the results we have here. And then 5 cancels 30 to give 6 plus 2 cancels 30 to give 15 into 2x minus 1. And so we have 5x minus 10x minus 10 equals 6 plus 30x minus 15. Collecting like terms again, we have 5x minus 10x, which is negative 5x, and 30x crosses this way to become negative 30x equals 6 minus 15 gives negative 9, and negative 10 crosses this way to become positive 10. And so this will be negative 35x equals positive 1, so that x equals negative 1 all over 35. We could have a quadratic equation like x squared minus x minus 12 equals 0. Then I will do the rapid factorization, which I know the factors would be 2 numbers multiplying to give 12. And when I add or subtract, I have negative 1. It should be negative 4 and positive 3. So those are the factors. So it's either x equals 4 or x equals negative 3 directly. you could have instead a radical equation with 2x plus 1 equals x minus 1, for instance. And in that case, to remove the root sign, I need to square both sides. So I'll have to talk of 2x plus 1 all squared equals x minus 1 all squared. And the square root and the square cancel. So I get 2x plus 1 equals, to expand this directly, I square the first term, then multiply the first by the second times 2 to get the middle term, and then I square the last term. So to square, I start by squaring the first term. X squared gives this. X times negative 1 gives negative x times 2 gives negative 2x, and then I square the last one, which is positive 1. If I send every term to the right, I will get that 0 equals x squared minus 2x, and then 1 plus 1, and then minus 2x, then minus 1. So that I will get on the right x squared minus 4x equals 0. X into x minus 4 equals 0, x equals 0, or x equals 4. Here you have to be very careful. Anytime you have a radical equation and on solving you have two possible values or more, you always have to verify the answer. One of them might not be a solution to the equation. If I take, for example, 0, the substitution of 0 for x on the left hand side will give me the square root of 0 plus 1, which is 1, and the square root of 1 should be equal to 1. But instead, when I substitute 0 on the right, it gives me but negative 1. The square root of 1 cannot be negative 1. The square root of 1 is 1. And so x equals 0 is not a solution. So x equals 4 only. That's the only solution. We also have equations where we just need to have x squared minus 4 equals 0. And to solve it, I have two approaches. I can just send 4 to the other side, and then x would be plus or minus the root of 4, whereby x would be equal to plus or minus 2. So there are two solutions, positive 2 and negative 2. Or I can use difference of two squares to solve, and it would follow that x is either 2 or x would be negative 2. The same result as up. It would also happen with the case where there is an even power of x, like 4 equals 64. Once I have that, it would be that x should be plus or minus. So each time the power is even, there will be two possible solutions, the positive and the negative. So we have the fourth root of 64 as the answer. Or simply plus or minus 64 to the power 1 over 4. And 64 is the same as 8 squared, the power 1 over 4. And that would give us 8 to the power half. The root of 8 is simply 2 root 2. Plus or minus. if the power were instead odd, x cubed equals 8, the answer will simply be x equals the cube root of 8, and that will be 2. If it was x to the fifth, another odd power, equals negative 32, we have that x equals the fifth root of negative 32, which would give us negative 2 to the fifth, all raised to the power 1 over 5. And you end up with negative 2 as the answer. There are equations which would be exponential. You have, for instance, a to the x equals b. I would have to use logarithms if a and b have no common base, so that log a to the x would be equal to log b, and x would then be log b all over log a. I could still use natural logarithms, and it would go here. Natural logarithm is appropriate in equations of this form, because where e is involved, it is only natural logarithm that will go. So if I had, for instance, e to the 2x minus 1 equals 2 to solve, I will take log to base e of both sides. That gives me ln of e to the 2x minus 1 equals ln of 2. And it would follow that 2x minus 1 ln of e equals ln of 2. Ln of e is 1 because it's like log of e to base e, and log of a number to its own base is always 1. Finally, we should make x the subject to get x equals 1 plus ln 2, half of that as the answer. We could also have log equations. If I had log to base a of x plus 1 equals c, I will need to convert first to index form, so that x plus 1 should be equal to a to the power c, and x will then be a to the c minus 1. From time to time, you would mostly be dealing with, again, log to base e or natural logarithm in equations. I could have ln 2x plus 1 equals 5. Then I would have to change it to log of 2x plus 1 base e equals 5, so that I now use the index form as 2x plus 1 equals e to the fifth. And from there, my x would be e to the fifth minus 1 divided by 2 as the answer.